During my career, the organisms I've been studying have become smaller and smaller. It started with big birds and then small worms in the benthos and then tiny plankton and unicellular organisms. Well, I started as a young kid as a keen bird watcher, and that brought me into groups that were interested in exploring bird life in the country and exploring also some bird migration. And particularly, there was a group gathering every summer at the Bird Observatory in Jutland. I moved to Copenhagen with a large part of that group, and we all moved into the same apartment building where each of us had a little apartment, and most of them started studying biology or other natural sciences. And so in that house, we developed a very rich social life, and at the same time, a theoretical interest in all the big issues in biology. And we learned each other and ourselves how to do the most important thing in doing research is to actually ask the right questions and also to find ways of solving those questions, answering those questions. When I had to do my master thesis, I had to do a little research project, and I started studying foraging ecology of shorebirds. But I soon became more interested in what they ate than in the birds themselves, and slowly I moved into deeper and deeper water. I started becoming interested in the organisms living in the free water marshes. Most of the biology is in the free water marshes, after all, if you look at the global ocean. And as you open up this world by use of microscopy and high-speed video and other modern technology, you realize that it's a very fascinating world. But you need a certain tunnel sight to be able to actually do research. You need to be able to throw away other stuff and select what you want to do and then do it. And the other thing you need to be able to is when you hit the wall, and you hit the wall oftentimes, you need to be able to have persistence to overcome that wall. And there it's an advantage not to be too smart, because too smart kids, they have never hit the wall. There's a famous ecologist, E.O. Wilson from Harvard, that wrote a book he called A Letter to a Young Scientist, where he describes exactly this. If you have an IQ about 140, you will never become a good scientist because you never learn to climb the wall. So I'm gifted by a sort of a medium IQ, and that's one of the keys to success, that you're not too smart, but that you are persistent and you have a certain degree of tunnel sight. And actually, one of the main sort of drivers of doing research is fascination. I mean, I was fascinated simply by the beauty of the plankton. And so my greatest moments in science have been when we, through physical considerations and by the use of mathematics, have been able to predict biological phenomena that you could not, think of from your intuition, and go out and observe those phenomena in nature or in experiments. That's the big moments. That's when you think, okay, it's worth it all.